back. Today we're going to be talking about the basics of the unit circle. More specifically, we're going to be focusing on the special right triangles with hypotenuse 1. So the unit circle is kind of a big deal. It's one of the biggest ideas you take out of trigonometry as you head into higher levels of math. Yeah, so we're going to be spending some time on this. We're going to spend a few classes going over the basics, making sure we understand how the unit circle is constructed and how all the parts work together, so that when you are finished with this class, it's something that you can remember and something you can take away with you as you head into higher levels of math. One quick story, I was talking to one of the university professors one time, and he said that he had a meeting with one of the incoming freshmen who was interested in doing math as a major, and he was being interviewed because his grades were borderline and his scores were borderline, so they were just trying to interview him to see if he had what it takes to do math in college. And the question that the professor asked him was about the unit circle, and because of the way his thought process of how he came to his answer, and because he knew the unit circle so well, the professor said that he was ready to go and he was able to major in math. So that's why I wanted to break it down so you guys understand the inner workings of this and have a decent idea, so that we don't have to memorize this whole unit circle going forward. All right, so we're starting off with the special right triangles, kind of like we were talking about the other class. So if we remember the unit circle as it is above, right, what we said is that there are right triangles that are inscribed within the circle, and because of that, each radius is the same thing as the hypotenuse of one of the triangles, and that's always going to be 1. So the radius slash the hypotenuse, because they're the same thing, of the triangle, is going to be 1 unit long. And because of that, that's why we call it the unit circle, because the circle's radius and therefore the hypotenuse of each triangle is 1 unit long. So let's look at the first example here. The main angle we're focused on when we're talking about the unit circle and the triangles that are inscribed in them is this central angle. In this case, our central angle is 30. That's the most important one. We know that the bottom right-hand corner is always going to be our right angle. Well, maybe not bottom right-hand corner, but the bottom angle is always going to be a right angle. And then the 60 degrees is a top angle. And we're really not focusing on the top angle, and we're really not focusing on the right angle, because the right angle is always going to be there, and then the top angle is just going to be the supplementary angle to the 30 degrees and the 90 degrees. All right, and we also said that the hypotenuse is 1. So for all of these triangles, our hypotenuse is 1. Again, if we have trouble locating the hypotenuse, it's always the side that's across from the right angle. All right, so let's talk about this triangle now. So what we want to do is we want to try to find out the length of each of these sides. We have this side, which would be the opposite side of the 30-degree angle here. And then we're trying to find the adjacent side, which would be it would be the adjacent side to the angle. So what we said from the previous lesson on special right triangles is that to get from the hypotenuse to the short side, so the hypotenuse to the short side, what we're going to do is we're going to take a half. So half of 1, that's easy to do. That's going to be a half unit high. And then we said to go from the short side to the medium side, short side to the medium side, what we're going to do is we're going to multiply by radical 3. So square root of 3 times 1/2. I made the square root of 3 into a fraction, so it's easier. It's going to be square root of 3 over 2. So what you're going to notice is because it's made up of all these special right triangles, these numbers are going to show up over and over again. The 1/2, the square root of 3 over 2, and of course the 1, the hypotenuse for all the triangles. All right? So now let's take a look at this next one. This is no longer a 30, 60, 90. It's a 45, 45, 90. And what we know about a 45, 45, 90 is that these two sides are going to be the same length. All right, so it would look like this triangle that we have drawn here in the unit circle, where this is the angle we're the most concerned about, this angle right here, which is 45 degrees. We are going to note that the other one is also 45 degrees, and then this angle right here is always going to be 90 degrees. But we're more focused on the 45, 45, 90. We also know that the hypotenuse, again, is going to be 1. And what we know is to get from the hypotenuse to the shorter side, we're going to do divided by square root of 2. So we're just going to take the 1 from my hypotenuse, divide it by square root of 2. And technically that is the answer. However, I'm going to throw this in here. I think we said it earlier, we need to do something special if we have a square root in the denominator. But let me give you some background on this. So back in the day of mathematics, before calculators and all that stuff, they said we don't like to have a radical in the denominator. And the reason why is because if we're thinking about fractions like 1/3 or 8/5 or something like that, where the denominator is a whole number, this is easy to conceptualize because really it's saying let's put one thing in 3 groups. So we can draw 3 groups and we can split the things up into those 3 groups. The same thing with 8/5. Like if I have 5 groups and I'm putting 8 things into them, that's conceptually easier to picture than if I have something like square root of 2. I don't know what a group of square root of 2 would look like, and no one would either. So they're trying to say that it's much easier to figure out what a whole number is for your denominator rather than a radical. All right, so it's something that we need to remember to do. It's part of simplifying any radical that we have in the denominator, and it's really easy once you understand how it works and what to do. All right, so the first thing we're going to do is we're going to multiply by the same denominator. So we're going to have square root of 2 times square root of 2 in the denominator. All right, so that's going to take care of the bottom, but we can't break any math rules, so we can't just do something in the denominator and call it good. It's not going to have the same value. So what we're going to do in the numerator then is we're going to multiply by the same thing. So really what's happening is if we're doing square root of 2 divided by 2, and we're multiplying it by the thing we had before it, 1 over radical 2, this thing, anything divided by itself is equivalent to 1. So we're multiplying it technically by 1, so we're not changing the value of it, we're just changing the way it looks. All right, so let's see what happens when we do this and simplify. So the whole reason we did this is because square root of 2 times square root of 2 in the bottom is square root of 4. Now keep in mind you can skip this step once you get good at it. And then in the top, 1 times radical 2 is radical 2. All right, so the magic happens in the bottom now. Because we have the square root of 4 and 4 is a perfect square, Square root of 4 is 2. The top doesn't change. And now this is the same as what we started with here, but this is in simplest form, because we have a whole number as the denominator. All right. Step 3 would be simplify. All right, so what we know here is that this is going to be square root of 2 over 2. This side is also going to be the same thing. And again, square root of 2 over 2, just like we had the 1/2 and the square root of 3 over 2, these are numbers that are going to be popping up over and over again. So yeah, we're going to be working with those numbers a lot as we work through the unit circle. Okay, one last one. So you can see this triangle is the same as this one. This 30, 60, 90 triangle, we're focusing again on this central angle here in red. That is our 60-degree angle. Again, our hypotenuse is going to be 1. That's the radius of the circle and the hypotenuse of the triangle. And now we're going to go just like we did in the first sheet of notes. To get from the longest side to the shortest side, we're going to take a half. To get from the shortest side to the middle, we're multiplying it by square root of 3. So our hypotenuse is 1. The middle side is square root of 3 over 2. And the short side is a half. All right, so you notice that these are the same numbers again as we had in the first example, except for this one, because our 60 is on the bottom as our central angle, the square root of 3 over 2 and the 1/2 switched places. The short side and the long side are in different orientations as the one we started with. The one we started with was like lying down a little more, right? It was in this orientation. 30 was here, so our 1/2 would be across from that one, the shortest side. And our middle side would be lying down because our 60 would be there. All right, so just something for you guys to digest. There's going to be some writing involved in this, but you're not going to have a lot of problems to do. I just want you to get super comfortable recognizing that, hey, if I have a unit circle and I'm talking about a triangle with a hypotenuse of 1, which orientation is it in? Where does the half go? Where's the square root of 3 over 2 go? Or in the case of a 45, 45, 90, where is the square root of 2 over 2? All right, so these things are going to help you build this concept of unit circle. Hopefully you guys were able to pick up on most of these things. Hopefully you remember from geometry some of the special right triangle stuff. If not, then hopefully you guys picked it up in the last assignment. All right, make sure you take your notes. Make sure you have any question. If you have any questions, you write them down, and then we can go over them next class. Good job today. See you next time.